Hi scholars, today we are going to talk about 11.3 specific heat. Make sure to have your notes out along with a calculator because we will be doing lots of calculations today. Pause the video and grab out your notes and calculator if you don't already have them. You should have had an introduction to specific heat from reading the article and answering the questions on the Google form. If you have not already done that, make sure to complete that first. Specific heat. We use the variable C to represent specific heat, and that is the amount of energy required to change a 1 gram sample of a substance by 1 degree Celsius. The specific heat of sand is 0.25 joules per gram times degree Celsius, and of water is 4.18. Based on the reading that you did, and thinking about that definition and the specific heats of those, explain why sand will be very hot in comparison to water during the middle of the hot day. Why then, if you go back to the beach at nighttime, is the sand really cold in comparison? Make sure you've paused the video and answered these questions. It is because high specific heat heats up slowly and cools down slowly, versus low specific heat heats up quickly and cools down quickly. So sand has a really low specific heat, so it becomes very hot very quick, versus it would take a lot longer for the water to heat up, or again cool down as well. Here are some practice questions. Pause the video and based on what you've already known about specific heat, answer these 4 questions. We'll go over these next week in class. We can also look at graphs like specific heat. It says heat is added to both aluminum and water as shown in the graph to the right. Read the labels on the graph and look at these lines and answer those questions. Pause the video, answer those questions, and again, we'll talk about them next week. Here's another set of graphs. Again, pause the video, look at all the important information on the graph, and then answer those questions. We're now going to transition to an equation that is commonly referred to as Q equals MCAT. This is the specific heat equation. In this equation, Q is going to be heat measured in joules. You may remember joules was a common unit that we used in physics for energy and different things like that. M, also in physics, we talked about mass, and it will be measured in grams. C, hopefully you remember this from the beginning of the slideshow, but C is specific heat, measured in joules, divided by grams times degrees Celsius. Finally, the delta, of course, is change. Change in what? Change in temperature. If delta T is not given to us, sometimes instead we'll be given the final temperature and the initial temperature, so we have to actually do the calculation. And that will be measured in degrees Celsius. Similar to the ideal gas law equation, if you ever forget what unit some of those numbers need to be in, we can look at the units for specific heat and see, oh, heat is going to be in joules, mass is going to be in grams, and degrees Celsius is temperature. Use this to help you out. These first set of questions is talking about change in temperature. Before we get to this though, let's go back to the equation. We can see how some of these variables are related. For example, since mass and heat are on opposite sides of the equation, if we increase the mass or how much of the substance we have, the change in temperature is going to increase. I'm saying that if the mass increases, the heat will increase. Or if we have a really big change in temperature, well, of course it's going to, if it increases in temperature a lot, of course it's going to be emitting more heat. Or if the change in temperature is a lot, then the mass isn't as much if the heat is the same, because of course, the more mass, the more challenging it is to heat up. And then specific heat, if if a substance has a high specific heat, it's going to have a high amount of heat emission. So again, change in temperature practice. Remember that our equation for change in temperature is final minus initial. A substance increases in temperature from 10 degrees Celsius to 80 degrees Celsius. What is the change in temperature? Well, our final temperature is 80 and our initial is 10, so we're going to do 80 degrees Celsius minus 10 degrees Celsius to give us 70 degrees Celsius. Pause the video, do the next one. You should have gotten 70K. If change in temperature is positive, that means the substance is heating up. And then, of course, if change in temperature is negative, the substance is cooling down. This is really important, so make sure to pause the video, write this in your notes, and maybe star it or box it so you remember that. How do we use this equation, Q equals MCAT? Here are the steps. First, we need to label everything in the problem. Make sure that the units are consistent. If you have a temperature in degrees Fahrenheit, for example, you will need to convert it to degrees Celsius. You also may see something that's in kilograms that you need to convert as well, or even kilojoules. Do the math. Use parentheses to separate the various numbers. If the unknown is delta T, solve for delta T, or the change in temperature first. Then reread the problem. Decide whether the delta T will be positive or negative. Remember, if heat is released, it will be negative. If heat is absorbed, delta T will be positive. Then calculate Ti or Tf with this equation. So you might kind of have to do multiple equations at once. This is our first example. What is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 10,000 grams of the substance increases from 10 degrees Celsius to 70 degrees Celsius? Our C is what we're trying to find. Our heat is going to be a positive heat because it is absorbed. Our mass is that, our initial temperature and final temperature. I can first check, are all my units what they should be? Yes. Next, I do my change in temperature to find my delta T. When I do 70 minus 10, I get 60 degrees Celsius. Next, I write my equation. Please write your equation, that will always help you. Plug in all the numbers and solve for C. Similar to the ideal gas law equation, sometimes I recommend students isolate the variable. So for this example, as soon as you write the equation, before you even plug it in, write C equals Q over M delta T. That could be helpful for you. If you'd like to do it that way, please do so. Therefore, this answer for specific heat is going to be 0.0417 joules divided by grams times degrees Celsius. If you don't have that written down yet, make sure to write it down. Our second example, we're trying to find the mass in grams. So we start by labeling all of our numbers. Again, we need to make sure, since the heat is rising, the temperature is increasing, we know that the Q, or the heat, is positive. So, excuse me. First, we need to find our change in temperature. We find that the change in temperature is 66 degrees Celsius. We use our equation Q equals MCAT, and we solve for M. Again, you could isolate the variable before plugging in your numbers to get M equals Q over delta C over C delta T, Q over C delta T. And we do our math. Of course, we need to now divide each side by 275.88, that should say that, to get 79.7 grams of water is what we have. You have a few more practice problems. Pause the video, answer these questions. For number 1, you should get the heat is 63,536 joules. If you didn't get this, If you're able to, ask a partner for some help. And 2 is 0.213 joules divided by grams times degrees Celsius. For number 3, you need to solve for change in temperature first, then you solve for final temperature, knowing that the initial temperature was 30 degrees Celsius. The final answer, so not just of change in temperature, but the final answer for the final temperature is 69.15 degrees Celsius. Next class, I'll check to make sure you have all of these examples completed with accuracy, so make sure that if you have any questions, you send me an email or ask for help from a student. Have a wonderful weekend.